So the question says, if alpha and beta are the roots of this equation, find equations whose roots are those things. So what do? Well, first thing to do is let's try and write this in a nicer way by adding some 1s. So we can rewrite that as 1x squared plus 1x plus k is equal to 0. Okay, and now we can easily identify what's a, what's b, and what's c, right? So if you have a quadratic in the form ax squared plus bx plus c equals to 0, then here we can see that a is 1, b is 1, and c is k. Okay, so now we're just going to solve the rest of this in terms of k. All right, so let's go ahead and do this. The first thing is, since we're doing Vieta, we need to set up the sum and product rules for the original equation. So for the original equation, the sum is equal to the sum of the roots, of course, so alpha plus beta. And that's equal to, always, negative b over a. What is negative b? Here we can see that b is 1, right? So negative b must be negative 1. That's equal to negative 1 over, what is a? A is 1. So we can just write it as minus 1 instead of minus 1 over 1. So alpha plus beta is equal to minus 1. Can we do anything else? Nope, that's it. So we move on to the product rule. Product rule says that when you multiply the roots, alpha times beta, you should get c over a. Okay? And what is c? C is k. So that's equal to k over a, which we already established was 1. So it's the same thing as just saying k. So we have alpha beta equals to k. Can we do anything else? For now, I see we can't do anything. Let's try and solve number 1, or number a, or letter a. So for a, it says now we need to find an equation whose roots are these. So we're going to start doing this, we're going to do the same thing we did here, set up the sum and the product rules. So for this new equation, the sum of the roots is alpha squared plus beta squared. And that is equal to negative b over a for that other equation, not for this one we just did. This is another equation for that other equation. But we can figure out what the b and a of that other equation are because we know what alpha and beta are from this stuff we did here, or we sort of know them. We can find them by moving things around. So let's see. Can we find any alpha squared plus beta squared here? Doesn't look like it. But actually, we can modify that first thing a little bit to get out an alpha squared plus beta squared. How do we do it? I'll show you how we do it now. So what we do is, let me use a different color. Use red. We can square this thing. So we square both sides of the equation. And then here, remember, when you square two things, two items like this in parentheses, then you have to FOIL them, right? So you end up with alpha squared plus 2 alpha beta, but I'll write that here, 2 alpha beta, plus beta squared, okay? And that's equal to minus 1 squared, which is 1. Beautiful. And now, we already know what alpha beta is from here. We know that alpha beta is k. So we can plug that in here. And so we end up with alpha squared plus beta squared plus 2k is equal to 1. And we can move the 2k over to the other side to give you minus 2k, right? And then we just erase this to keep everything nice and short. And then we have now alpha squared plus beta squared. Isn't it just beautiful? So we have alpha squared plus beta squared if we erase this plus here. Okay, hopefully you see that. Let me highlight it. We've figured out alpha squared plus beta squared. And we already know, we're going to come back to these. We already know, let me get a nice color here. Alpha plus beta is equal to minus 1. And we also know that this one, alpha beta is equal to k. Okay, so let's get back to this. Now, alpha squared plus beta squared we saw as 1 minus 2k. 1 minus 2k. Sorry, let me use my black color rather. 1 minus 2k. And that's equal to negative b over a. Now, this isn't a fraction, but we can write it as a fraction. We can write it as 1 minus 2k over 1. And therefore, we would then say that the a is 1. And the negative b is 1 minus 2k, which would mean the b is the negative of this thing. Okay? So we'll get back to that in a second. And then finally, we have that we haven't found c yet. So we found a and b for this new equation. And we need to find c. So let's work on that. So for that, we use the product rule. So for product, we have the product is going to be the multiplication of these two, of course. So we have alpha squared times beta squared. which is c over a. Okay, and we can rewrite this as alpha beta squared is equal to c over a. And do we know alpha beta? Of course we do. We found it here. Alpha beta is k. So this is k squared is equal to c over a. And again, we can rewrite this as a fraction. We can just write it as k squared over 1. And we will say that a is 1 and c is k squared. So a is 1 and c is k squared. And so our final equation then, we have the a of 1. So our final equation will be ax squared, or 1x squared rather, so x squared, plus what is our b? Our b is the negative of this thing. Let's do that. So if negative b is this, then b will be equal to negative of 1 minus 2k, okay? Which would be what? Minus 1 plus 2k, minus 1 plus 2k. Okay, so our b here, let's write this better. We can write that as 2k plus 1. Sorry, 2k minus 1. Okay, that's neater. Okay, so then our b here will be 2k minus 1. X. I might be confusing you. Let me write this out nice. So what is our a? Our a here, we said was 1. So a is 1, which is basically nothing. Our b is, what is our b? Our b we said is 2k minus 1. 2k minus 1 there. That's why you have to have the x. And then our c is k squared. So k squared there. Plus k squared is equal to 0. So this would be your final answer there, this one. Beautiful. We move on to the next one. Let me, what should I do with this one? Should I delete it or should I try and shrink it? Let's see if it'll shrink. Okay, go over there. Let's try the next one. All right, for the next one, it says that the roots are minus alpha and minus beta. So we do the same thing we did before. So now we're doing for b. So we have that the sum of the roots is equal to negative alpha plus negative beta, or that's just negative alpha minus beta. And that's going to be equal to always negative b over a for that new equation. And can we work this? So have we found negative alpha minus beta anywhere? Not really, but we found alpha plus beta. Can we make this look like this? I think we can if we factor out a minus 1. So we factor out a minus, and we end up with alpha plus beta. Beautiful. That's equal to negative b over a. And now we can plug in this alpha plus beta, which is minus 1. Plug that in there. And then we have minus 1 is equal to negative b over a. And so 1 over 1, you can think, is equal to negative b over a, which would mean that a is 1. And if negative b is 1, then b should be negative 1. Right? So now we found a and we found b. Let's see if we can find c using the product rule. So for product, we have alpha, sorry, not alpha, negative alpha. So our roots here are negative alpha, negative beta. So we have negative alpha times negative beta, and that's equal to c over a. So negative times negative is positive. So positive, and then alpha times beta is just alpha beta. So alpha beta equals to c over a. And have we found alpha beta? Yes, we have. We found it here. It's k. Beautiful. So we plug that in here. K is equal to c over a. We can write k as a fraction, k over 1. And now we have that a is 1, b will be negative 1, and c will be k. Beautiful. Okay, so if we have an expression like this, an equation like this, then our a is 1, so 1x squared, or just x squared. Our b is negative 1, since negative b is 1. So instead of plus bx, we have minus 1x, or minus x. And our c is k, so plus k is equal to 0. And that will be your final answer, for the second one. Let's try the third one. Let's see if we can shrink this one. Get it out of the way. Okay. So now for c, this one is probably going to be the hardest one because it has a compound roots there. So here the roots are alpha minus 1 and beta minus 1. So as always, we set up our sum. So sum is going to be equal to the sum of these two roots. So we have alpha minus 1 plus beta minus 1. And that will be equal to negative b over a for that other equation that we're going to figure out. And let's see, we can simplify this to give us alpha minus 1 plus beta minus 1, which of course is alpha plus beta minus 2, equals, and we bring down this negative b over a. Now, can we simplify this? Yes, because we found alpha plus beta. Alpha plus beta here is negative 1. So we plug that in. Negative 1 minus 2. Oh, it's so great. It's so nice, these things. So we have minus 3 is equal to negative b over a. We can write negative 3 as a fraction, negative 3 over 1. And then we have a is equal to 1. And if negative b is equal to negative 3, then b should be equal to 3, right? So now we have a and we have b. Can we find c? Let's see if we can find c with the product rule. So for the product, we have that we're going to multiply these two by each other. So we have alpha minus 1 times beta minus 1, and that should be equal to c over a. And we multiply this in a compound way. So we do alpha beta. Which way should I do it? I do minus alpha minus beta plus 1 is equal to c over a. Can we simplify this? We do know alpha beta, right? Alpha beta is k. So let's do that. So we have k. But how about this stuff? Minus alpha minus beta. Have we seen that before? Not exactly, but we have seen alpha plus beta. So we can make this look like alpha plus beta. We've done this before. We factor out a minus 1, or just a minus if you like. So it's minus alpha plus beta plus 1. And alpha plus beta is minus 1. So we plug that in. So finally we have k minus minus 1, because alpha plus beta is minus 1, plus 1 is equal to c over a. Okay, c over a here. And then we finalize this. So we have k plus 1, which is k plus 2 is equal to c over a. We can write this as a fraction, k plus 2 over 1. And now we have a is 1 and c is k plus 2. Just as we saw there, a was 1 and there b is 3. So now we have, if we have some expression, ax squared plus bx plus c equals to 0. Then for this one, we have that a is 1, so just x squared. B is what? B is 3, so plus 3x. Sorry. And c is k plus 2, so k plus 2. That's equal to 0. And that is your final answer for that one. So you see, it's really quite simple. You just simply set up the sum, set up the product, and see if the expressions that you come up with, you've been able to figure them out from past work that you did. Okay? And this one just looks funky because it has k in it. But as you remember, they asked us to solve in terms of k, so we just solve it normally. Okay, so that's that one, and I wish you luck.